Hello, so today I'm looking at M3 International A-Level January 2016. This is question 6. So in part A, I'm asked to use algebraic integration to show that the centre of mass of a uniform solid hemisphere of radius r is at a distance of 3r over 8 from the centre of its plane face. So the plane face is this circular face here. So I can draw this diagram here. Here I've got x, here I've got y, and if I know that this is r, then I know that y squared plus x squared is r squared. And so rearranging this, I get that y squared is r squared minus x squared. And so now I have defined this line here, this curve, and in order to work out where the centre of mass is in the x direction, I can use the formula pi x bar y squared dx is equal to pi y squared x dx. Okay, so basically pi times the integral of y squared dx is the volume of revolution. So in fact here I can make use of this formula that they've given me for the volume of a sphere. So if the volume of a sphere is this, then the volume of a hemisphere will be half of this. So on the left hand side I would get 2 over 3 pi r cubed. So that's the volume of the hemisphere, which is everything there apart from this x bar, so then I need to write x bar. And then on the right hand side I can write this integral. So I have pi multiplied by y squared x, but y squared I know is this, so I have this multiplied by x. So r squared x minus x cubed, which needs to be integrated with respect to x. I'm also going to need some limits. And I can see from my diagram that the limits go from 0 to r. Now dividing both sides by pi, I'm ready to integrate the right hand side. So here on the left hand side I have 2r cubed over 3 multiplied by x bar. Here I have, remember r squared is constant, so here I add 1 to the power of x and divide by the new power. Add 1 to the power and divide by new power, to be evaluated from 0 to r. When I put 0 in there, I'm just going to get 0, so I only need to consider what will happen when I put r into here. And to get x bar, I'm going to need to multiply whatever this result is by 3 over 2r cubed. Okay, so from here I get, putting r into the value into x, then I get r squared times r squared, which makes r to the 4 over 2, and then putting it in there I get r to the 4 over 4, so basically I get a half minus a quarter of r to the 4, so I end up with r to the 4 divided by 4, so because a half take away a quarter is a quarter. Okay, so now just tidying that up, then this will cancel with that, and so I'm left with 3r over 8, which fortunately is what they said it should come out to be. So that is 5 marks for that part of the question. Next I'm giving this picture, and it says a uniform solid hemisphere of mass m and radius r is joined to a uniform solid right circular cone to form a solid S. So the whole thing is S. The cone has mass capital M, base radius r and height 4r, and the vertex of the cone is O. The plane face of the cone, so here this circular face, coincides with the plane face of the hemisphere, so they meet here on the circular face, as shown in figure 3. Find the distance of the centre of mass of S of the whole thing from O from here. Okay, so here I can use a table to help me. So if I begin by saying that S is the cone plus the hemisphere makes S the solid joined, which is formed by joining both of those. Sorry, it's a terrible drawing, but anyway. Okay, now they said that the mass of the hemisphere is little m, and they said that the mass of the cone is big M, and so therefore the mass of the whole thing is going to be m plus little m. Next I need to find the distance of, that's my ratio of the masses, and then I can do the distance from O of the centre of mass of the cone, centre of mass of the hemisphere, and then the centre of mass of the whole thing. So for the whole thing I'll call it x bar, and for a cone I know that the centre of mass is 1/4 h from the plane face, so therefore it will be 3/4 h from here. So here I'm doing 3/4 of the height, which is 4r. So I will just end up with 3r. For the hemisphere, the centre of mass is going to be, the distance from O will be 4r plus this extra distance from there to where the centre of mass is, which is what I worked out in part A as 3r over 8. So if I do 4 plus 3/8, then I end up with that whole thing is the same as 35r over 8. So now I can do basically moments. So this times this plus this times this equals this times this. So I end up with capital M times 3r plus little m times 35r over 8 equals capital M plus little m times by x bar. And I'm looking for x bar, so I will just try and write this in a bit of a nicer way. So if I make everything over 8, then let's try 8 times 3 is 24, so I'm going to end up with 24. I've got a common factor of r. So I'll take that out. Sorry, right, common factor of r. Timesing this by 8, I end up with 24 capital M, and here 35 little m. That was all over 8, and then I can divide it by capital M plus little m there, and that will give me x bar. Now I'm given the point A lies on the circumference of the base of the cone, so somewhere along here. This solid is placed on a horizontal table with OA in contact with the table. So let's say A is this point here, then that means my table is going to be here. The solid remains in equilibrium in this position, and I've got this inequality. So if I make a similar drawing, but this is just 2D, and on here I've got the value that I just worked out in part B, x bar, and rather than trying to draw this like a different way round, now that I've drawn that, I can just draw in where the horizontal will be and where the vertical will be. So that is O, this point here is A, and it said that OA is in contact with the table, so this is my horizontal, and therefore the vertical is going to be here, and I'm interested in this point here, and I've got a right angle here. Okay, now now that I've drawn that, then what will happen is the centre of mass will act downwards, and I know that it's going to act inside this part here somewhere, and so I know that this distance here is going to be less than OA, because the centre of mass, for this to remain in equilibrium, will act vertically down but must fall inside this length here. If it were to fall outside, then it would mean that this would tip and would no longer be in equilibrium. So it might be useful to call this something like theta, and then to write down what I know using this triangle and this triangle, because I've got another right angle here. I know from the diagram that this length here is r. I know the length from here to here is 4r. That's that entire length there, from O to there. I'll just call this m. And if I've got a right angle here, and that's x bar, this is theta, this is x bar cos theta. So what I'm going to say is that, using this, is that x bar cos theta is less than OA. So now I know what x bar is because I worked that out in part B, so I need an expression for cos theta and I need an expression for OA. So for cos theta I can use this triangle here. I know this is 4r, I know this is r. If I work out the hypotenuse, OA, then I can get that OA squared is 4r squared plus r squared, so I get 17r squared. And cos theta would be the adjacent over the hypotenuse. So the adjacent would be this from O to M over the hypotenuse, which is OA. So that will be this square rooted, so I get square root of 17r. So in fact, these two r's will cancel. So x bar, I need to go back to what my value was from part B. Here is my part B, so this is my value for x bar. So x bar is r over 8, 24 capital M plus 35 little m, over big M plus little m. So that's x bar. Cos theta is 4 over root 17, and I know that is less than OA, and OA is root 17r. Okay, that's looking good because the r's are going to cancel. Root 17 times root 17 will make, oh sorry, actually I could put an equal sign here as well, because this could be less than or equal to, so long as the centre of mass kind of falls, even if it falls at A, this will still remain in equilibrium. Right, sorry, root 17 times root 17 is 17. So that went there. The 4 and the 8 will cancel and give me a 2 on the bottom over here, which will then become a 2 up here on the right hand side. So this, and this are accounted for. I'll put the m plus m on the right hand side, and then I'm left with this bracket on the left hand side. I'm trying to end up with capital M basically as the subject. So here I get 34 capital M, and if I take away 24 capital M, I'll get 10 capital M. Here I've got 35 little m, I've got 34 little m on the right hand side, and so if I take away 34 little m, then I'll just end up with little m there. And now dividing both sides by 10, I end up with capital M is little m over 10, which fortunately is what they thought that I should get to, and so that part of the question is worth 5 marks. So you have 5 marks from part A, 4 marks from part B, another 5 marks from part C. I hope you found that solution helpful. Good luck with your studies.